Olympiad 10, question 3. So, in this question, we have the following equation. A over 11 plus B over 3 equals 31 over 33. Well, the question is, A and B are whole numbers. Find the value of A and B. Now, we know that these two can't be decimals because they're whole numbers, which means that now we have to figure out what these two equal. Well, let's see first. Well, when you're doing addition in fractions, the denominator has to be the same, correct? In that case, this should be 33. And this should be 33. By doing so, we now multiplied 11 times 3. Now, remember this. Whatever you do to the bottom of the fraction, you have to multiply the top. Since we multiply by 3 here, we have to multiply A times 3, which would give us 3A. Here's why. Think of A as apples. If you have 1 apple and triple the amount, you will have 3 apples, correct? Which is why 3 goes in that area right there. Now, same here. Since B was over 3, 3 times 11 equals 33, which means B times 11 equals 11 B's. Think of B as a bee. You have 1 bee, and it gives birth to 11 times of its amount. You would have 11 bees. Well, now we know that 3 A's plus 11 B's equal 31. From here, it's pretty much guess and check. So let's start. If A equals 1 and B equals 1, then 3 plus 11 equals 14. That can't be right. If A equals 2, which is 6, and B equals 2, which is 22, it equals 28, which isn't correct, but we do know that 28 is 3 off from 31. Wait, that means that we're skip counting by 3 over here, which means that we can add another 3 over here. So if we have 3 A's, so 3 A's, which equals 9, plus 2 B's, which would equal 22, we get 31, which is correct. Which means that if we have 3 A's, then A should equal 3. And since we have 2 B's, B should equal 2.